Yes, sir.
Okay. Mr. Jabir. Hello, Karthik. How are you?
I'm doing good, sir. Thank you. How are you?
Okay. Yeah, yeah. Doing fine as well. So I think We can wait for another couple of minutes and then we are in a good position to start.
Yes, sure.
Karthik, your voice is a bit low. Is that a problem from my side? Are you being able to hear my voice clearly?
Yes, I am able to hear your voice clearly. How about
Your
now?
voice is having a bit of echo.
Okay. How about now?
A bit better, yes.
Okay.
Two more minutes and we can then start, right? Karthik?
Sure. We'll wait for another 3-4 minutes. I think we'll get over.
Okay. Hi all. Till what time this class goes on?
It is 2 hours. It is another a bit less than 2 hours.
Okay. So till 9:30?
Till 9
Up to
o'clock,
9.
Satish.
Till 9.
Okay.
Because after this, there will be another 2-hour session for DevOps. I think, Karthik, we can start the session.
Just give me 2 minutes. I'm setting things up.
Sorry?
Just give me 2 minutes and.
Sure.
Yeah. Can we start the recording?
Hello.
Yeah. Is it my voice clear, Dev?
The voice is a bit on the lower side, but it's okay. You can.
How about now?
I mean, for others, how it is? Are you being able to see? Sorry, hear Karthik's voice?
Yes, it's good for me. No issues.
Okay, that's fine. That's fine.
Thanks. Let me start. Can we start the recordings?
Hi. Yes. Yes, Karthik, the recording is on.
Thank you very much. So, good morning, good afternoon, good evening, everyone. Welcome to the 8th session for Internship Cybersecurity Internship Program. Today, we'll be talking about a very important concept and one of the concepts which is very key, but I think we have seen, which is not given much importance in a real-time scenario, right? A lot of people don't understand the particular concept, what is happening out there. So that concept, what we're talking about is password management. So in this today's session, we'll talk about what is hashing, what is salt, what do you mean by salting, and we'll also see how do we, if I get access to a password hash, how do I crack it using the John Ripper tool. Then again, we'll also see how to use Hydra to crack SSH. And if time permits, we'll also see how can we use burp suite to hack into our normal day-to-day application, web application login page, how we can be used to hack that component as well. So we'll see all these three components. Just a second. So my question here comes up is, right, whenever you're registering yourself with websites like Google, Facebook, or Insta, or anything else, any large company, any good organization, you have to register your user, all right? So there you'll be given a login, that is your username. And again, you're going to be using a password as well. Okay, and you will always remember the password, right? It is one of the three forms of authentication. Password is there are three. What are the three forms? Something you know, right? Something you are, and something you have, right? Password is something is in your brain, so you know about it. Something you are is nothing but your biometrics, right? And something you have is like an access card, okay, which can be used to get inside the organization too. And one of this form is password that's going to be there. So my question here is that, do you think, let's say I'm opening my Gmail account and Gmail may be something like care 76911 at gmail.com. This is my mail ID and the password is something maybe as password at 123. Correct? This is what my password is. Do you think, my question to you guys, do you think this password is stored in Gmail? Remember, whenever I enter password, this is the password and Google is going to verify this password is right or wrong. But is this password getting stored in your Gmail? Right? Anyone has any idea for this? So let me ask you one more thing, right? And put for thought. Whenever you click on forgot password, why is that you have to reset the password and not get the old password? Right? Why do you think this is happening out here? Whenever you click on forgot password, you can only reset the password, meaning you can create a new password out there, but you can never get the old password. Why do you think? The reason here is that websites never store your password. Meaning wherever you go, maybe Google or any other website, they don't have your password at all. Right. So my question is, how do you know? How do you know? How does they verify your password is right or wrong? How does your website do password is right or wrong?
Can I ask a question though?
Yeah, yes.
But if Gmail doesn't store it, I want to believe that when you're creating it, there's a database that's responsible for saving that token that you created when you're using that password. So if Gmail doesn't store it, then where's the database that's responsible for that?
It does not store your password at all in any form. If they're storing your password in clear text, right? If this is my password, as I told, if my password is password123, if they're storing this information as a plain text in any database, this is policy violation, security policy violation. And if there's a bigger organization and like Google is doing about this, they will be prosecuted for that.
But
Technically speaking.
Okay, but if they store it as an encrypted form, isn't that I don't know. I'm just thinking.
They don't store it in encrypted format as well. They don't know what is your password at all. So it is not like so what
by like a hash. It's represented by like a hash.
Yes, it's going to be taken as a hash out there. So if you're going like an encrypted format, what is going to happen is password123 is going to be there. So I will not store it in plain text. I'll convert it into encrypted text. Then I'll store it in the database. Okay. So whenever I do the next time the login attempt out here, I'll enter by both username and password. And this password is taken. And from here, it is going to be decrypted and the password is going to be compared, right? This is what you're thinking. But this does not happen out there. So we can, the plain text password, right? Plain text password is never even stored in an encrypted format. The reason is when I decrypt it, I'll still get back my older plain text password, right? So at that time also, I don't need to do a reset password. I still can decrypt it and get the password process out there. Okay. To overcome this scenario, what is going to happen is that there is some component, something called as a hash. This is a one-way cryptographic algorithm, right? As a cryptographic function that is going to happen out there. And this is predominantly used to check, right, whether the component is good or wrong, right? Whether any modification is being done or not. If you see in cryptography, it is also important to check the integrity of it, right? And that is very much important. So it will be able to identify if the modification is there. Same logic is going to be used for your, application, right? For your storing your passwords and everything. For instance, let's say, where do you think your password is stored for your Linux users? In a Linux environment. Just a second. I don't have a calculation. Let me open my Kali Linux. So where do you think your Linux password is stored in a Linux environment? Or where do you think the user information is stored? Okay, we'll look into that in a second. Exactly. ETC password is going to contain information about the user, but does it contain the password for the information for the user? There are two very important files that are present in a Linux environment when it comes to users. Okay. Traditionally, what used to happen is that in an early days of Linux, there's a file called etc passwd file. This is where all information related
sorry, Karthik.
Yes.
Your
screen is not shown.
Yes.
So traditionally, all information that is related to a user is going to be stored in etc passwd file. A lot of other things, including the password. The problem with passwd file is that every user in the OS will have access to it. Okay, so it was quite easy to look at other users' password and things and all. So what they did was they moved that application process to one more file called shadow file. And this file contains the information related to your password. Okay, so let's look into that files. First one is etc passwd file, and you could see here. Okay, let me do one thing. Let me see just one line. One. Okay, here you could see there is a particular user created out here called Kali Linux. This is the username, and this is the user ID and the group ID of that particular user that's going to be there. And this is the home directory, just like your My Documents you have, right? So every user will have a home directory. It is telling what is the home directory of the Kali user. And it is telling the default shell belonging to that particular user out here. That is, they're using ZSH shell out there. If you go for Ubuntu or any Rocky Linux or anything, you will get a bash shell out there. Okay, ZSH is also used in your Mac systems. That's as far as I've seen. Okay, but you see here there is an X mark out here, the second component. This is where was previous password was stored. Okay, the previous password was stored out there. So then they saw that it is not secure, so they moved it away from there. Where did they move it? They moved it to shadow file. Right, this file you need to have root permission. That is why I've logged in as root user. Otherwise, you have to use sudo to open this particular file out there. These two files are very important. Why? Because if I can access, let's say if I'm able to do command injection, kind of an attack on the web application, I'm able to run some command on the Linux server where the web application is running, I will be able to know all the usernames that are present in this particular system. Okay, I know there's a root user, there is a lot of services will also be given a username that is there, and new user, whatever the other users are there, it is also going to be given out there. For instance, let's say I will create a user called John out here and see it is asking me for password. I'm going to just give a basic password of that. And if I go back to that file, you could see that particular user information is again stored here. So getting access to this getting access to this file is very important. I will know the name of the users that are there in that system. Okay, that is very, very important out there. And here you could see there's one user called www data out here. And this is the user used for running your web application. All right, for instance, let's say system control. When you open in the browser, there's a web server running out there. Right. This particular page is executed by the Apache, and then HTML page is generated for this and it is sent to the browser. So who is doing at the server end? The Apache is doing, and Apache is given the username as www data. Okay, where is it? Yes, it is here. So any request sent to an Apache server on a Linux administrator, this is going to be given as www data. Right? In a Debian base, it will be www data. And if you are working on a Red Hat based system, it will be HTTP. OK, this is what is the difference out here. So now, what is the shadow file? Right? Shadow file contains the password for all the users that are present out there. So let me rerun this. OK, now you can see there are two different files lines out here, which is important. Users, this part is going to be empty except root, right? Except root and except Kali and John rest, because Apache you cannot log in as Apache, so no login is given on them. Okay, let me do the same process again. Let me one second. It's not filtering. Is it capital? No. I just want a 3 lines. Yes, it's good. Here, and this is where your password for each of the user is stored, right? For Kali user, the password is Kali. For the root user, password is root to TOOR. It's a reverse of root user. And for John, the password is just PASS. That is as simple as that. But can you get back the information from this component? And this is where your password is stored out there. And again, rest of the things are all related to this is telling how long your password is going to be valid for. If your password is going to expire after 30 days, this will not be 9999, it will be 30 out here. So when I have this number, it means the password is almost never going to expire for you. And other things, what is the time before that you can start getting the telling an information that when your password is supposed to encrypt and how long it's been the previously password has been set for, other information that are there, which is not of importance to me when I'm talking about penetration testing component on that. So my question here is that, so this is where the information that is going to be present on, and this is the hash. And whenever I create a new password, the value is going to be changed as well, right? For instance, let me change, if you see here, the component out here, I will change the password, passwd, if I can give John. I'm running this command as root, so I don't need to do sudo permission, right? So I'm going to change the password for John user, and you will see the value is going to change as well. The last line is going to change as well. I'll give password, okay? And I rerun the same thing. You can see the value is no longer the same, this particular component out here. So what is happening here? Even in a Linux environment, your password is never stored physically on the hard drive. There's never going to be stored up there. If I don't have the password, if I don't know the password, right? How do I, when I enter the password, how does it analyze if something is what the password you have entered is right or wrong? That is my question. So how does it know? So for this, we are going to use a hashing algorithm that is going to be there. Hash is very simple. What it's going to do is that it is going to create a long string that is of fixed length, irrespective of size of
Karthik,
component. Yes.
someone is complaining about Soji. That it is not audible.
Okay. Let me do one thing. Can I leave the session and join the session and see? I don't know.
I can hear you.
No, I think it's their settings. You're audible, sir.
Yeah, I can hear you
Okay.
fine too. I can hear you
Yeah.
fine.
Okay. Good. So now there is a simple hashing algorithm, right? Let's say you have a very large file. Okay. You download it from somewhere. And how do you know that is a legitimate file or not? For instance, let me see if I can copy this into my Kali Linux.
Can I ask a small question?
Yeah, please go ahead. Yes.
So does it mean that even if you run the RSA, it's never even physically stored on the machine?
Yes. It's never stored on the machine physically.
That's weird. Okay.
No, that's a good way of going about it. The reason is if you get hacked, right? So my question is, if you get hacked, your password is disclosed, correct? So what are the chances that you're going to use the same password everywhere else? So how many of you have the same password for your Gmail, same password for your Facebook, same password for your Twitter, and things? So how often do you use the same password in multiple locations? Right. So as an hacker, I have to hack one place and rest where I'll be able to do that component, right? So it may be possible for me, it may not be possible for an hacker to gain access into Gmail database and things that is there. But let's say there is a smaller website somewhere who is not capable of giving you very good security. If you're storing your password in plain text there, it is easier for the hacker to gain access to the server and gain access to your password. So all he has to do is to do that component of that. Right, hashing is not 100% safe. It is still crackable. We'll see how do we do that over here, but it takes more time over there to do that activity. Right. So now, so let's say I think it is not copying. So, for instance, let me. There is one file in Rocky, Kali Linux, right? Kali, one of the main reasons we are using Kali Linux is because it comes with a lot of pre-existing tools out there. It is going to be used for doing our activity. Okay, so this particular text file, right? It is having around 14,344,392 passwords that are available worldwide. So it has a huge list of passwords of that, and this is one file contains that information of that. Okay, so now what do you mean by an hash of that, right? So for instance, this particular command is used to check it will, when you run it through an hash, it is going to give you a particular value for you. Okay, this is a particular value, and remember, as I told, this hashing algorithm is used to check is there any modification done to the file, and this particular file is having 14 million lines of data in that. Let's say I will do one thing. I'll do echo. I'm going to add 0. I'm going to append it to the end of the file. Okay, so now it will have one extra line for that. Instead of 392, I'm having one extra line of the Now, if I calculate the hash algorithm for the same thing, you will see the hash is changed significantly. So this is one way of knowing if your data has been modified or not. And nowadays we ask people to hash their code and everything, right? Before you're going to take the code to push it to it, it would be a good idea to take your source code to hash it and things. Whatever the file it is going to be, it is does not mandatory need to be a text file also. It can be your executables and everything. For instance, if you go to Kali Linux to download your virtual machine, if you download Kali, and any legitimate software will give priority to security, they will have this data out here. When you go to download it, see here, I want to download the VMware version. You can see there's something called as a sum out here. Okay, so this is going to be in hash value for that ISO. That is the zip file out here. So this is a zip file out here, right? If I do the SHA-256 sum out there, I should get the same value that is present out here. Even if it is changed by a single character here, it is not the same. It is not the same. You should not go ahead with the process of it. This is what a hash is going to be. Hash can be so good when it comes to identifying changes. Let's say there is, billions of zeros and ones, right? In a 1 petabyte of data. What is petabyte? 1024 zettabytes, and what is 1 zettabyte is 1024 gigabytes, right? So that is what I feel. I think so. Even in that much big file, even if one is changed, one of the zeros in a binary level is changed from 0 to 1 or 1 to 0, the entire hash is going to change completely. Entire hash is going to change completely. Okay. So this process is going to be used by us for for doing our authentication in our day-to-day activity, right? So why now? What is going to happen? We are going to logging into the, let's say this is your first time and opening your Gmail, right? So you create a user. You create, let's say I'm going to use Karthik 123 at Gmail. Okay, that mail ID is present. Then I'll give the password as pass at 123. So what Gmail is going to do is that once you send this information, Gmail is going to create a hash value for your password. This password hash value is created, and this hash is stored in the database. And this is deleted permanently after that. So let's say the hash value, just for the sake of argument here, we'll do it as 1234 ABCD. That is going to be the hash value that is stored in the database. It is going to be very complex, right? So now, when the user logs in after some time, let's say we log out and log in again, during the login process, what you're going to do? You're going to give a username that is Karthik 123 at the rate of Gmail. And you're going to give password as pass at 123. Right? This was the one thing you had kept it out. So when this information is going to come, it is going to check whether the Karthik mail ID is present or not. It will be present in the database. But how can it compare whether the password entered by me here is actually the legitimate password or not? So what it is going to do is that it is going to take this hash value, which is already there, that is your 1234 ABCD, and it is going to take the you entered password out there, pass at 123, push it to an hash value, hashing algorithm, and then it is going to get 1234 ABCD. Now it is going to compare both of the hashes that are there. If both are matching, then means the password you entered is right. If the password you entered is wrong, the hash value is not going to match. Right? That is, yeah.
Does it mean that whilst it's still trying to evaluate that, it will traverse through the binary tree and try to figure that out, whether to verify it, whether it's the correct one or the incorrect one?
Yeah, so it is going to check, it is going to do hashing algorithm on it. For instance, let's use the hash sum as an example for our case. Okay, let me create one file called touch pass.txt. Okay, so now let me, so I'll just give my password as insert pass at 123 colon. I'm going to save it. So what it is going to do is that it is going to save it in the database. What is the algorithm for that? Right? So what I see here, whichever the size it could be, it may be 1 terabyte of data, 1 GB of data, 1 petabyte, or just going to be 4 characters. The hash length is going to remain constant. The length will not change out here. OK, and let's assume this is what the data is in a database. It is stored here. OK, so now when a user enters the password, it is going to do the same process and it is going to put that in a file and it is going to check for that, right? If you are changing, let's say echo. Let's say the password is different out here. Now I'm going to give that same. Right. So now it is going to check both the passwords are same or not. Right now, since the hash value is not going to match, it is going to be a mismatch of it. But both of them are having pass at 1 to 3 only, right? What is happening in pass1.txt? Right. Both of them are same password. Why is it is mismatching? Here you could see that I have given the capital letter in the second file. E is capital out here, and here it is going to be small letter out here. Even one thing changes a little bit also, it will not take. The hash value is supposed to change significantly. That is the point of it. So that is how it is going to be done out there in your end. And all the websites, that is never good. This is the reason why you're always going to reset the password. You can never get the original password from the hash value. You can never get the original text back from hash. That's the component out here. So that is the reason I can never retrieve. I can only check whether it is valid or not. Okay. So now how do you think? Yeah. Yes.
Now, quick question. In this case, does it treat a password update as a rewrite? Like it would
Yes.
have to.
Yes. Yes.
Okay.
It is going to update. For instance, what is the correct way of changing any password? If you saw me here when I gave pass WD John, right? This is I'm entering as a password changing for John as a root user. So it is not asking the current password for the user. OK. So let's say if I'm logged in as John user, SU John. OK. As a John user, I like to change my own password. Pass WD, it will ask you for the current password. Right. First, it will take your current password, see an hash is matching or not. If that hash is matching, then it will take the newer hash which you created for the new password, and it is going to update in the database. Right. For instance, right. So for instance, let me use as a root user only because I don't have to enter current. And again, if you're not going as a root user, password policy is going to be managed out there. So that's why. So let's say we'll go with the cat/etc shadow file. OK, you see the value out here for the John user. The component what we see here is your database, the hash value of your password for that particular user. For John user, This is the hash value for that. And now let me change the password for the John user. Passwd John. Let me give it as password itself. Right. And if I rerun the shadow file, and you will see the value is changed significantly. Okay, you see here, this part is not the same out here, it is changed there. So every time you make a changes, you append a password, you make modification to password, a new hash value is generated for that, and then it will be updated out there. So that is how it will go. But the hashing algorithm is still not secure. Okay, and one more thing, this $y is going to be there in all your Linux. It specifies what hashing algorithm is used, because the hash value will change depending on the hashing algorithm. Okay, for instance, we'll do it and I'll show you. There are different types of hashing algorithms, right? One is SHA-256. There are other things. Let's say if I give, you can see SHA-224, 256, 5 and 12. A lot of other things are there. So I can do SHA-256 sum, right? I'm doing it for pass.txt. See the value. And again, I'll do it for 512. There are two different algorithms. They are very similar, but different algorithms. You see the value changes significantly. The hash value changes significantly out there. So we need to know what algorithm has to be used out there. And that is why the shadow file will contain the algorithm to be used for creating a hash value. Okay. But still, even though hashing algorithm, you can never go back. And other things can be done. That I will talk about it, how to crack it. How do you think I can go ahead and crack the hashing algorithm? How do I crack passwords, right? Even after I'm having this component out here, it is still going to be cracked, right? So still Linux admin, I can still will see, we can take the same file, shadow file, and we can crack the password. If the hash is not reversible to the text, how is that I can crack the password according to you? What can be done to crack the password here? Any idea? This is where the brute force will come into play. Okay. In this situation, let's say what has happened is that I have hacked into the server. Okay. And now I have somehow I have access to the shadow file. Okay. So my question is, via the shadow file, you take the hash and how do you crack the password? Let's say your Gmail is storing all your hashes and Gmail server database gets hacked. And what I've got is a complete dump of what? Dump of hash of all the users that are present out there. So I need to crack the passwords for each of the user. How can I do it out there? So what it is going to do is that, if you remember, I told $y is this is an hashing algorithm. It knows it is going to use this as the algorithm to know what to do. Okay. So my question is, what do you mean by brute force? What do you mean by brute force? Any idea? So brute force, what is going to happen in brute force is, let's say I got to know a user is there. By default, all the systems will have a root user. Okay, this is a permanent user for all Linux. In your Android, your Mac, your iOS, everywhere except Windows, you will have a root user out there. Okay, or some other way you got to know there is one more user called student that is present out there. And you want to crack this. So what is going to be there? Let's assume there is no hash. The database is storing the password in plain text. So what do you mean by brute force? So what it is going to do is that, let's say this is password is supposed to be what? It is supposed to be 4 character long, and it is supposed to be only between 0 and 9 is the combination for 1 character of that. So what I'm telling is like a PIN code for your ATM card or a credit card, right? You will have 4 characters, and the maximum possibility is for single character is anywhere between 0 and 9. So what is the maximum possibilities here? 9,999. Technically speaking, including 0000, you will have 10,000 possibilities out there. Okay, this is what is going to happen. So now I'm going to brute force means first I'm going to select 000, second I'm going to do 001, I'm going to 002, then I'm going to 003. I keep on testing one by one, and everything. I will see which one is going to break. Which one is going to break. And technically here after 10,000 maximum, let's say even it is 9999, maximum of 10,000 tries, I'll be able to crack this password. And this is called as a brute force. Okay. For your 8-character password, the possible characteristics for a single character are A to Z. This is capital, uppercase, lowercase. You'll have 0 to 9 and special characters, right? It could be out there. Technically speaking, if you're having an 8-character password like this, we saw this rocky.txt, right? So how does the rocky.txt look like? Each and every line is having a separate password out here. It keeps on going. It's about 14 million lines that are there out here. And our 14 million lines is around almost, how many MB file is this? Right, 133 MB is there. That is how it is a small amount. If I'm going for an 8-character long password, even if I'm using all these parameters, technically I could not create it because I didn't have enough hard drive space. The password text file will be 4 terabyte. Right, it will be very long. You'll need a lot of time to brute force it, but still it is possible out there. So now let's not assume this process out there. Let's assume the brute force is possible. The student name is the username is student, and he is having a 4-character password, and that is from 0 to 9, 4 character. The maximum possibility is there. And let's say the hash value is something like, what is it going to be? Could be, for an example, hash word is 1, 2, 3, 4, A, B, C, D, right? I don't want to take very big numbers and everything for training purpose. Okay. So now how can I crack it, the hash value for this? How can I compromise this? So you remember, I have something, I know that Linux server is using $y. That is a TrueCrypt algorithm, hashing algorithm that is designed for hashing password files. Okay, passwords that are there. So what I'm going to do is that here the brute force, first it will take 0000 and convert into hash. And this hash is compared with the hash that I'm presented at there. It will not match. It will take the second value, convert into hash, and it will check, and it will keep on taking 1 character, converting it to hash and doing it out there. And everything is going to be checked one by one. And this is going to need to be done, right? That is how you crack it. That is how you can do it. Okay. So now instead of directly checking the password is matching or not, right? It is taking what? It is converting this file into this password into an hash and checking with the hash or possibility is there. That is how it is going to do. Yeah.
Are we we considering salted hashes or rainbow table?
No, I'm going to come to the salt. The reason why we are using salt. It is going to be there, right? There is an issue with the salt hashing problem. That is the reason we are going to use the salt out there. Okay. So now this is the process that we have to do. And this is how you crack a hashed password. You're taking a brute force list of passwords, something like rocky.txt, and converting each and every line out there into an hash and comparing whether the hash value is matching or not. So that is how it is going to be done. But still there is some kind of an issue. Why? If we take an organization, let's assume there are about 500 people. There are about 500 people are there. How many of them do you think they'll be using something like this password at 123? Right. And the worst case scenario, this is one of the most commonly used passwords. Right. If you take a list of passwords that are going to be there, it's very common out there. Okay. So password at 123. Let's assume 20 people are using this. 20 people are using it. Now, all I have to do here is that as an hacker, I just have to crack one hash. Okay, because password 123 is going to remain constant for all 20 people. The hash is going to remain constant for all the 20 people because the password is same, the hash is going to remain as well. That's the point out here. So anyone running this same password will be having the same hash value. So all I have to do is for one person crack the password. And once I've got that, I don't have to worry because I don't have to, for remaining 19 people, I don't have to do the brute force attack. Why? I already have the password for them. The hash is already going to be there. And especially when you take a very large, right? So that is going to be one more thing again is that as I told 8-character long password, it is going to be 4 TB. The hacker is not going to be using this process. He's not going to try out each and every process out there. Okay. So what he's going to do? He's going to use file like rocky.txt. Okay, rocky.txt is going to be there. There are certain places online you can get that information, the latest password list and things. It will start checking instead of going 4 TB. I can do 14 million lines is going to be not that difficult. And one of the hashes is going to crack. Some of them is going to be there and then it is going to be present out. It can be processed. So now how do we overcome this situation? What is the situation that's going to be there? Right? Because all the users, all 20 users are pass 123 they're using, and everyone's hash is remain going to constant of them. So how do we overcome this particular problem in the password hashing method also? So what they do is that they're going to add something called as a salt. They're going to add something called as a salt. So now this makes two things difficult. It is going to make cracking password even difficult. And again, it is going to make sure all the hashes are unique to that particular person, even if the password is matching. So what is this? Just like we're adding a salt to a cook and everything, what I'm going to do is that I'm going to create, let's say, 4 users are having the same password out there. Okay, let me user 1, user 2, user 3, and user 4. So it will pass at 1, 2, 3, right? So now salt is just that a fixed random string that is going to be appended to your password. It could be anything that is happening out there. That is a randomization algorithm that is going to be present out there. For instance, what it will do is that here it will just add ABCD 13 X A 15 GH or GE 69. some random string is going to be added to the password. Both of them are going to be combined, and then a hash is going to be created for that. Then a hash is going to be created for that. So in the database now, for a user, it is going to have password hash, right? Complete thing that is created will be stored here. Along with that, it will have one more table called salt. Okay, so this will, for that particular user, it will tell ABCD is the salt. For the second user, it will tell 13XA. Third user 15GH is going to be given out there. So now what is going to happen is that the hash value is going to be completely different. Hash value is going to be completely different for all users, even though the password is same. Even though the password is same, the hash value is going to be completely different. And that is what we see in the shadow file as well, right? When you see the shadow file, right? So you could see here what your password is actually, your hash is only this much, right? So other things that are present here are nothing but your salt value and other information that are required for password auth. Okay, so that is what is happening. So that salt value is going to be added to everyone, and for every user, the salt value is going to remain different. For instance, let me do one thing. Let's create one more user. Add user Alice. Okay, password is pass. Okay, and I'll give John user also. I'll make sure password is pass itself. Okay. So now since both of them are having the same password, the hash value should be same for both, but it is not going to be same for the both. Why? Because the salt is different. So for pass, they are going to add this salt value and then it's going to be combined and created the final hash value into that component. So now what is going to happen? What is going to happen here? Very simple. Whenever user enters the login information, is going to enter the password as. So previously I should take this password, convert into hash, and the hash was going to be compared up, right? This was happening. But once the salt is introduced, this cannot be done. So what they're going to do is that they're going to take the password, plus they're going to add the salt that is there in the database, then combine and create a hash value, and then compare it with the hash that is created out there. And when both of them are matching, this is going to work exceptionally well. This is going to work exceptionally well, and I can crack it. Even though multiple users are having the same password, it is still not going to be crackable. Again, everywhere I have to redo the entire process. Okay. So can anyone tell me, based on previous way of looking, how do we create, compromised or brute force and hash password? How is this salt base, adding salt is going to increase the password complexity? How can it make it more difficult to crack it than the already existing approach? So now let's assume.
What if we use rate limiting encryption?
So rate limiting exception. So see here, rate limiting, what does it do? Rate limiting is there to prevent brute force, right? So let's assume you don't have a mechanism for preventing brute force. So you need to have another mechanism. Let's say rate limiting is possible when you're entering the login information to the server, right? Server can tell, okay, you attempted 3 times. I'm no longer going to give you access to that. I'm locking you out. But let's assume the server is stored the password hashes in some database, correct? The hacker comes in, steals this data. Now, this hash value is with the hacker. Can I implement rate limiting now? No, right? Because in this application, you'll know how to run. You will take the database, you'll take what is the hash, then you will run a program on the hash value. right? The encryption script that's going to try to crack it. Now we can't do anything. There's no rate limiting mechanism out here that it can prevent it. Okay.
Oh,
So once
oh,
it is
then
gone.
okay, then it means
Yeah,
we can
please go.
use a two-factor. Then we can use a two-factor instead of using that. Then instead of or we maybe combine them both.
Two-factor authentication is used for a different reason. Okay, it is used for a different reason. It is going to add one more layer of security. Two-factor authentication is not going to be that difficult. All right. For instance, if we saw about session management, a session ID is given to you, right? Session ID is given to you. You can be subjected to CSRF attack out there. So someone can trick you into selecting an action performed on the website without your knowledge. In that case, let's say someone tricks you into doing a transfer to someone else's account, money from your account, someone else's account. So when you add a multi-factor authentication, that is, it could be two-factor or three-factor. That when you add that, that is an extra layer of security that is giving and telling that, okay, this cannot be done. So that is going to be there. So we are not going into that factor out here. Okay, two-factor comes in, but that is taken into consideration once you are compromising the process. Okay, so that is not, we cannot consider that here perspective. Okay, it is important. It is important to have two-factor authentication, but so if you remember in SSH, we're using public key encryption, right? That is much safer than using a password. That cannot be cracked. Some cases it is better than two-factor authentication. So how do we do this process? Previously, let's assume for the password for here, password is 4-character.
Karthik,
Yes, sir.
could you check the chat, please?
So this is the salt value that is present out here. What we're getting out here. So let me just a second. So you may be thinking that is the salt value is going to change. Okay, see here. Okay, I've not created a password. Why is this? So let me see that you're asking is the salt value changed? Let's see how that. Run the same thing. And you can see here the salt value is changed here. Only thing that is changed here is that the password I entered was same. In the previous password itself, both the cases, the password was pass itself. And it is changing the salt value that is going to be there. And salt value has to be completely random. If there is an algorithm specified for that, there's a pattern for that, I can really make use of it and crack it. Okay. If you're telling sometimes certain algorithm, because computers is having one major problem that it cannot do something random. Okay. If I'm telling you tell me a random number, you can tell 9786676 something. That is completely random. That is coming out of your head. There is no reasoning behind that. But computers can't do that. They have to find some way of doing it. Certain times it will look at your mouse movements and then create a random value. It will take your date and time in the things. Like if you take a date and time, it can be it can be decrypted also, right? The salt value is not going to be much different. That is that. So we have to be extremely careful when you're taking a random values, and salt is always going to be random. There is no meaning From a computational perspective, that is going to be random. There is a process of it getting out there, but it cannot be predictable by humans. What is that? It's going to be. Right. As you can see, this is the username. What is the algorithm that is used here? So it is telling MD5 hash and blowfish. So these are the different types that are there, right? And you are using SY out there. This is called let's encrypt, S encrypt out there. You can see salt used to encrypt the password. So random, chosen to random 6 to 96 bit size that is going to be present out there. Did it answer your question, Karthik? So now let's come back. So how do we crack? It is still possible to crack. See, if you have enough computational resource, you will be able to crack, right? There's a lot of science and process and goes into that. A normal hackers will not do this. Usually this is going to be done by state actors, right? State actors meaning a bigger espionage, GCHQ, it could be your NSA, it could be your, whatever the country cybersecurity division, who have a very high quality professionals, and they have a lot of mathematicians. They will know the behavior and do all those things, right? That is, they can pinpoint. We can create a list of passwords the user can have based on their name, if you have their Facebook account or anything, social media, if you know a database and everything, their relatives like brother, sister, wife, it can create a custom list of passwords that is going to be. We are limited to password creation. Okay, so now let's understand how do we crack a salt-based hash algorithm. Okay, so again here I'm using a simple analogy, 4 characters 0 to 9 possible. So it is going to be 0 0 0 0, then XX 4 possible. For this I'm going to add salt as well, and this is also going to be 4 character and 0 to 9. Okay, so now for cracking this, right? So what is going to happen? So it is going to now, previously what was the maximum possibilities? It was 10,000. So now cracking this approach, what he has to do is that it has to take the password 0000, then it will take salt value and it will exhaust all the possible salt values for a single password that it want to brute force. So you see here the 00 is going to remain same. So it is going to keep on adding out here. And once it reaches 009999 here, then it will go to the next password value that can be brute forced. Then again, it is going to start from 000 here. And it keeps on going out there. So previously it was only 10,000 possibilities out there. Now it will go to 10,000 into 10,000. Okay. So that is why when there was recently a disclosure, what is the time taken to crack a password? They tell it depends on the salt value. It depends on the salt value out there. So for instance, how long do you think a 8-character password can be cracked? Whatever you're using in the office, right? They'll tell once in 30 days you have to supposed to change your password. So this I'm talking about 10 years back. So at that time they told an 8-character password, they were asked to change in once in 30 days because it takes 30 days to crack an 8-character password, 45 days. Okay. So by the time the password is cracked, your password is already changed. The password is already changed. So you're always ahead of the hacker out there, right? Unless until you're using something like this, right? Jan at 2025, Feb at 2025. For every month you're changing, just adding NAR at 2025. You're doing like this, then the hacker would have, by end of February, you would have cracked your January password and he knows what is the pattern. So in the month of March, he is going to try this password and then it is going to be crackable out here. Okay, so that is the concept that you have to be very careful. So now tell me, in current situation, right? So you will see a number of days. You will see one particular chart is widely available out here. I could see it. Let me show you this. So this is not an accurate depiction of what is happening. That does it take so many days, right? So for instance, they're telling a number of characters in the password. If it is 4 up till 10, right? From 4 characters up till 10 characters, it will going to be instantly cracked, right? When you're only using numbers, right? When you're using only lowercase letters, it takes about for up till 7 characters, it is instant. For 8 is going to be 5 seconds. For 10 characters, it is going to be 58 minutes. When you combine both uppercase and lowercase in your password, you can see it keeps on increasing the case, right? Number uppercase, lowercase, and if you see here, number uppercase, lowercase, letters and symbol, an 8-character password can be hacked in 8 hours, and a 10-character password takes about 5 hours, 5 years, right? So this is not something your desktop can do. Okay, please don't think that in your desktop you can instantly. Some of them can be done, like a 4-character password can be done instantaneously. But when you go with this, it is going to take time. This is done by high quality. So you will get specialized gaming servers that is going to be used for cracking passwords. Why? These servers will have a graphics card. You can see there are about 8 graphics cards. There's a expensive servers. The reason why they're using these machines is that they're exceptionally good at calculations. Graphics cards are used for doing all physical calculations that are there, right? For when you play video games, a lot of physics is there because gravity and everything has to be calculated. When you throw a ball in your game, it has to bounce, it has to reach a certain place. A lot of calculations occurs out there, right? So the same thing needed for cracking passwords, because hashing again is a mathematical calculation that is going to be there. So you need a lot of math power. So it's something a grid like this is going to crack 4 billion brute force, 4 billion passwords. Means it is going to create 4 billion hashes, not per day, not per hour, per minute, I think per second. This is 4 billion different variations that is going to be there per second. That is when it is going to work. Okay. But as I told, this particular table is not accurate. Why? Are they considering the salt value also here? It is going to change. So for instance, what I mean to say is, let me consider the password is just going to be password itself. Okay. So now what is the length of the password here? According to you, it keeps changing, right? The password length is constant, 8-character long, but your actual password that is stored in the hash value, it is going to change. Here it is going to be 12-character. Here it is going to be 13. Here it is going to be 16. And here it is going to be 18-character long. So I as an administrator, when I'm designing an application, I can tell the developer, see, when you're storing the password, make sure the hash value, the salt value is of certain number, higher than that number that is available out there. So make sure that is the scenario, how it is going to be. So it will be in my hand. So even though my password is only 8-character long, if it is something like a 16-character long, it will take how many 10 trillion years to crack with your current computational speed, right? 7 quarter. So for 17 characters, right? So that is how difficult it's going to be. for trying. I'm not talking about quantum computing. It will break quite faster in quantum. It is going to be breaking very soon, right? In a couple of days maximum. We think it is going to break in a couple of seconds, minutes at least. That is going to be there. And it is already shown certain calculations, which will take thousands of years. It has done it in a couple of minutes in a quantum computer. So breaking a password is not going to be difficult for it. Right. So this is the reasoning for that, why you need to have a very long password. The longer the password, the more difficult it is going to break. Even after breaking 4 billion different password attempts, 4 billion password attempts per second, it will still take this many years, 15 billion years, 1 trillion years, 93 trillion years. That is how much time with the current computational speed. Okay, as the computational speed increases, it is going to be easier to, this number will go down drastically. Okay, so the computational speed will keep on increasing. Okay, so and this can go significantly down, right? If I'm using multiple gaming rigs, if I'm using a supercomputer for cracking it, right? So that is going to be there. Okay, so these are the number 17 or 18 character number. It will take a very long time even for supercomputers, right? That is the reason why NIST says that whenever you are an administrator password, you're in super admin or an admin, it is telling that minimum supported password is 16 characters. Okay, don't keep it less than 16 character password for an administrator. Then you add another 8 character of hash salt of that, it is going to be unbreakable via brute force, right? We are talking in terms of brute force only, right? So that is the reason there is no way to crack nowadays guessing or brute forcing. That is why a lot of phishing attacks goes on, trying to people to give out their passwords. Supercomputing, yes, as I told you, it will still take time. Machine learning, that is what, right? What is the possible passwords that could be out there doing the, let's say there are certain machines, certain programs or tools in Kali Linux, I don't know which ones others have showed, where you can give a certain set of strings that are there, and it will predict what could be your password, right? So let's say most of the time people will have their loved ones' date of birth in the password and combination with letters. It could be their home address, it could be their previous address, their dog's name, their pet's name, and everything. We put everything out there. Instead of getting billions and billions of passwords, it will bring it down to few thousands out there, and then it is going to be trying to crack it, right? But still, right, there is again the salt value that is there, which is totally unpredictable. That will make things cracking very difficult out there. Okay, that will make things cracking very, very difficult. It is not going to be, it is still possible, right? If I get hold of your actual password, it may not be possible to crack here, but for a web application purposes, it is possible to crack there, right? So it is always, that is why we tell security is also a multi-layer approach. Just salting your passwords may not be sufficient. As one of them pointed out, rate limiting should be present out there. That is going to add to that. Then again, right, there are multiple things that you can add, make it secure, right? One is salt you can do, long passwords you can do. This is everything combined I'm talking about, right? Then enforce rate limiting, right? For instance, you will see when you do SSH, we'll try to do the SSH bypass using passwords, right? You'll see it can go through thousands of requests in a single second. We'll see how to reduce that. Okay. Then we can also do geotagging as well. Geotag or specific IP address. So for instance, when you can configure SSH to be accessible by a particular IP address. This particular IP address belongs to the administrator, laptop or desktop, whatever that are using out there. It is very specific to that itself. So no one else will be allowed SSH into that. So if they're not allowed, how can they do the brute force? That's the thing. So everything can be compromised, right? Everything can be compromised. There is nothing called as 100% security. Only thing is that we can increase the level of difficulty to crack a password or compromise a code. Everything is possible, right? Let's say, what if I want to access a particular data? You might give all types of security out here. And one day you will kidnap the administrator, put a gun to his head, and ask him to connect to the server and give the data to you, right? He's still going to give it to you, right? Then what is more important for you, right? That is the right. Only thing is that we have to make it more difficult. Understand what is your importance of data. Then based on the importance of data, we're going to add more security to that. Right. And that is one of the reasons why there's a lot of background check when you're doing with government secret web, applications. There's a lot of background check is done. They not only check for your criminal records, they're also cross-check criminal records for your friends, family, and their friends and family as well. Okay, they're not going to take the risk of all those things out there, and they'll be constantly checking your behavior as well for that process. Okay, so that is how we can compromise a particular process. So now let's see. So any questions, guys, till now? Any questions? Is everything is clear? So is my teaching that good that everything is clear in the letter? Let's take a 2 minutes break. Then we'll start again. Just take a 2 minutes break. In the meantime, if you want to, speak in the meantime, you can do for couple of minutes.
Yeah, sure. Thank you, Mr. Karthik. So I think this is the last session for cybersecurity free internship, right, Mr. Karthik?
Yes, this is the last session.
Yeah, because guys, our cybersecurity, like I think we are doing this thing for this particular session. We are doing for last 7 weeks. So today is the end of cybersecurity. Our AI sessions is going to take, because we do have a Friday free classes as well, but that was a little bit tough for everyone. So once we are planning to move our AI internship, instead of Friday evening, we are shifted. We are going to shift to in Saturday morning. So many people, because yesterday we got many requests that hey, it is very late for us. It is a Friday evening, so many things. So yeah, that's true, but we hadn't any other option, because cybersecurity we cannot lift in middle of thing. Our cybersecurity classes has already started, and I think this Monday or Tuesday. So still it is how is going, Mr. Karthik, the new batch of job ready training?
Yeah, it's going on right now. So we are in the initial stages. We have completed a little bit of basic Linux, like perform package management, process management, and things. So this week we'll be continuing going to the advanced level. So security and services like SSH, firewall, and all will be covering this week. So if someone is willing to join, they can still join and catch up. That's it.
Okay. And we are planning to start our AI job ready training and DevOps job ready training very soon. In the matter of fact, we do have another session with Mr. Devashish for our DevOps one, the free internship, the free sessions after Mr. Karthik cybersecurity session ended. So keep us posted and keep joining with this kind of classes, so you'll get idea about those domains. And if you have any question regarding your cybersecurity, AI, or DevOps job role, job hunting process, feel free to ask.
Can I continue, Mena?
Yeah, please.
So we will see a simple example, right? So how do we use the password to crack the password for the shadow file, right? So let's assume some way your server gets hacked and you're going to be able to get your hands on the shadow file out there. So how are you going to crack the password for those users out there, right? In this case, we're having 4 users. One is root user and one is Kali user, that is a default user in Kali Linux, and Alice and John, which we created recently out there. And how do we go about doing the process of that? The process is not that difficult. First of all, we have to create, right? We have to create a place. We need to have a password list for this, right? One of the best password lists is rocku.txt. But what is going to happen is that rocku.txt is very long and it will not be, it will take time if we use that entire process to do the lab out here. So what I'm going to do is that I'm going to take about the 10,000 lines from it, first 10,000 lines of the file, and store it in a password file and use that as a word list. Okay. And it is going to cross check with each and every word. It is going to do brute forcing for each and every word for cracking password for each of the user out there. So now let's do. So you can see here, what I'm going to do is tail -n 1000. What is the file name? docu.txt. Right, this is that. So I'll do the head. I think probably that would be better. First 10,000 lines. Okay, so now I put it into a small docu.txt, right? And this small docu.txt will have all the 10,000 lines. So if you can count it, it's telling. So, okay, it's only 1,000. Let me do it. 2,000. So first and foremost here, what is required here is to combine your passwd file and shadow file. For that, it is important. Both of them should be in a single file required for that. For that, you use a command called unshadow, where you're going to give both the locations of the password file and the shadow file, right? Then you're going to put it into a, let me, I'm going to give unshadow.txt. Okay, and press enter and creating a directory. So you can see it is combined, both of them. And you could see here previously, if you remember past etc file, this is the location that was showing as X. Now it is combined, taken that hash value from the shadow file and put it in the passwd file and created a new file. That is what is happening out there, nothing else. So rest of the only 4 of these lines are going to be correct. Rest nothing is going to be correct out there. Okay. And before going further, I'm going to add, okay, when if you don't have the passwords of the user in the password list, it is not going to be cracked. Okay, that is very, very important. I'll not do it here. I'll open in the text editor. That would be better. So I'm just going to add root pass Kali password 123. This is very much important. If the user's password is not there in the password list, it is not going to be correct. So you need to have that process out there. So by default, rock you should have one of the most commonly used. If you're using a complex password, it is not going to be possible to crack it using this. Okay, so we have unshadowed it. Now what we can do is that we can use the John the Ripper, John word list. Let me get what is the command out there. Right. Okay, so this is very, very important, the way you're running out here. So here I'm telling what is the password list file, where is the location of this. So in this case, the password list is passrocky small rocky.txt, and it is also telling what is the format of the hash, which is the algorithm that is used for that. And $y means it's a crypt format that is there. I'm going to use it, and I have to tell what is the shadowed file name as well. That is there, and you can run this, right? And now it will keep on running for all the different variations. It is going to do that. It is going to take a long time for doing this process. Let's wait for 2 minutes. Let's see if it is able to crack the passwords for all of them. Right. If it is not that, we'll remove the word list. We'll have it very small and we'll try it out. So each of the password, understand here, it does not have to do brute forcing for the salt. Why? This unshadowed file is already having the salt value. So every file in the text, every password here is going to be taken. That particular salt is going to be covered. Then it is going to convert into an hash, and that hash is going to be compared with the past shadow file that is having out there. This hash is matching or not. Once that hash matches, then it knows what is the password is going to be out there. Okay, so this is happening in the background for all the pros, for all the users that are there. So this will take quite some time, right? If you want to reduce the time taken, what you can do is that for experiment purpose in real time, this is going to take, right? So this is just an example why your password management in your real-time scenario, when you are going to go as an architect or security architect or an threat modeling person for an application, you should always talk to them, make sure the password length complexity is important, the length is of certain characteristics, and also while storing, make sure that the salt value is also bigger of that. Okay, and one more thing I want to ask is that do you think hash and salt is going to be stored in same database? Do you think it's a good practice to store hash and salt in the same database? So meaning one table will be there. So here you'll have username. So you'll have the hash, the salt. Right? Like, but it is there in the Linux, right? Everything is there. Username, password, hash, and salt is there. In that situation, it is available. It's allowed because you are running a standalone system out there. But when we talk about big organizations like Gmail and things, you should not store the salt in the same database, predominantly in the same server. Also, it is not a good idea. Right? Why? If this database gets hacked, the salt is also getting hacked out there. It will no longer provide the security it is supposed to provide if it is stored along with the hash. So always store the hash in a separate database, and then while collecting, it has to be combined, collect information in both the places and run it out there.
Does it also mean that you then have to also employ data mapping when it comes to the data flow? Let's say we're speaking about.
Yes, that is what, but again, it will come down to depends on what kind of a data you are protecting out there, right? So if it is something like KYC, know your customer information, where your social security number, your official address and all those things are there, the security should be very high. Okay, let's say if you're going to give the same thing for gym membership, right? You're giving some basic information, you're giving your name and phone number and credit card information. The security that much is not required up there. Having a separate database for your hash and everything, don't do those things. That's not required. Right? And if you remember, one of the reasons why a lot of websites today are using third-party payment gateways is for the same reason. When you have an in-house payment gateway, there's a lot of restrictions on you, how you're storing that credit card information and things. So you don't, if you're a small organization, your budget will not allow to give that much security. So they go with third-party payment gateway and they will take care of the security of that. Right? So that's how it will go. So let's see if, yeah. See here, it took about all 10,000 variations, meaning it took around 40,000 different attempts has been done for each user, and all the passwords has been broken for all 4 users that are there. For Alice, it is telling password is pass. For root, it is telling tour. And for John, it is pass. And Kali Linux, password is pass. Kali. Right. So it took about 40,000 tries in your normal. I'm running in a small VMware machine. It took about a couple of minutes. Think about same thing happening in a large machine where it is designed for cracking passwords. It will be a lot more powerful out there, right? Even if you are able to do it in your system with a graphics card, this is going to be a lot more faster in that. And because the virtual machine does not have access to the graphics card, so it is going to take time. Okay. So that is how you can crack the process of it. So the longer the salt does not get access to the salt, and then the password is long, it is going to take more time to crack it. Right. So because by default 14 character, 14 million long, it may not be sufficient in some cases. And if you're going to give it a try, this is going to have a huge impact. Okay. So now my question is, salt is there in the background, and it is going to be useful when you are going to provide security if you can get access to the database of the password. But we'll also talk about why it is important to implement rate limiting. For instance, when you're doing SSH, right? The login access here, you're going to send the password only, right? If the password strength is weak out here, it can be broken much faster. Okay, we will see, because when you are connecting from a remote machine, salt is going to be no use out there. Okay, so for instance, we'll see here. I'm going to connect to one more virtual machine, and there I'm going to set up a, we'll see if SSH is present there or not. If SSH is there, we'll try to hack that SSH from my Kali machine out there. Just give me a second. The latest Ubuntu version is behaves differently. Takes time. Let me check if SSH is there or not. Yes, it is there. So let me start it. System control. Start SSH. Okay. What is the IP address? 192.168.178.163. There's for cracking SSH, there's one tool called Hydra. Okay, we'll try to use that. So we can use Kali tool. A lot of tools. There's a tool website called Kali Tools, and go and you can check. It will have all the information. How do you do the process for that. Yeah, this line is important for us. So we know, let's assume by some way we know the username out here. So we want to crack the password for that particular username and that is present out there. So let's paste it. So let me explain what is happening out here. Hydra is a brute forcing tool out here that is used, and it is telling I want to crack the password for the user student out here. And where is the password list? In this case, I'm not going to use the basic available out here. I'm going to use my same small rocky.txt itself. And -t stands for it is going to establish 6 different connections and try it out. So meaning it is going to increase the speed rather than trying each and every password one at a time. It is going to try 6 different passwords using 6 different connections and then it will try to break. OK, so it is going to check the IP address 192.168.163 is right. Is that right? Yeah, it's been long I have to use this tool. Right, so this is telling I'm using SSH is the protocol I'm going to use out here, and then that is the process it's going to do. So press enter, right? So now it is sending a lot of information, right? Let's say so here is jumping. There's a Wireshark, it's telling what is the process that is happening. Since I've kept the passwords that are there in the last lines, so it might take time to compromise. It is 163 only, right? Yes. So this is one way of cracking SSH. Here the salt value is not going to be of importance. Why? Because I'm just sending the password here. The salt is going to be calculated by the SSH service. So it is its problem. That is not going to be an issue. And that is why having a long password is going to be important out here. And having a rate limiting mechanism in place is also important out here. Since there's no rate limiting specified out here, it is able to do a lot of tries and still get away with it. Right, it is giving a little bit slower out here. So what we can try to do is, probably reduce the password length out here, and then we can go add those things out there. I'm going to raise it to just predefined 200 passwords. Okay, because the same process is going to be whichever the length. It is just going to take more time. That's all. So in the meantime, any questions, guys? from the password process, what exactly is important, how to hash, why hash is important, how do we crack, and how do we crack a SSH service as well using the Hydra tool. Any questions here? It is telling what another 2 minutes time is there for it to go through it. Let's wait for a minute and so, and we'll see. I don't know. Predominantly, this is some activity which we use in hacking labs and things. But in real-time scenarios, we don't see it happening quite. Why? The main reason is when you have a password policy set properly, this kind of an attack related things is not going to be that easy for you. Okay, it's going to, that is why it is important to have a lot of these issues and things will be mitigated just by making sure you have a very good password policy. At the same time, if you are going to have a proper, hashing. So here it is telling for the user student password is passed and it is corrected. Right. So it is you here in this case, there's some kind of an rate present out there. That is why there is a limitation to given for 250 tries. It took some time. OK, we can even further reduce it if you know how to configure SSH out there, or if there is a firewall in place preventing particular IP address. All those things can be taken into consideration. Right. So that is how it is important. OK, so if we had a very long password, this would have taken days, and days meaning you will see can see the different amount of data that is coming in network traffic. If you are doing log analytics in your server, you will be able to identify someone is trying to break the password, trying to compromise the credentials. Then you'll be able to take away with that part. So I know this is a bit, difficult, it may be a bit too much to consume. If you have any further doubts, reach out in the WhatsApp group. We'll be able to help you in that part, right? And probably if the more doubts you're having, send out the questions, and probably in the next sessions, future sessions, we will make sure the internship is designed in such a way that your questions in this case will be answered as well for the future students. That will be great. So that's it, guys, for today.
I think for the month also, because this is the last session for cybersecurity. Don't worry, those who are joined very new, we are going to start our cybersecurity in fresh session the next after a couple of weeks later, because Mr. Karthik also need little bit of his personal time, because he is doing this thing and Mr. Devash is doing this thing for last 2 months now, and it is he has everyday classes, and this is a free session in the weekend. So now we are going to utilize this gap with our AI session, and hopefully within a month or so we are going to start a fresh session for our cybersecurity. Right, Mr. Karthik?
Yes, yes. So please give your inputs as well for future sessions. You might know what we have done. And if there's any particular topic in cybersecurity you're interested in, if we get sufficient, demand for that, we'll try to add them as well. So that will be good.
Yes, like every, I think this is our third terms where we are our third consecutive sessions we about our cybersecurity. Now every session consists of 8-9 weekend session, right? 7 to 8.
Yes.
Now every times we try to put some new topic to make it more, worthy to our people like Ernest. So
Correct.
because Ernest,
So initially,
Ernest,
we remember we had only 4 weeks of cybersecurity. Now more and more demand, more topics. So we have added more things as well. So yes.
yes, because there are many students who join from day one and they completed, I think, 3 into 7, more or less 21 weeks with cybersecurity. So every new batch we try to add some new features or new topics which it can put more value on those who are keep joining with us. So thank you guys. Now we do have another session with Mr. Devashish for DevOps, and I think Mr. Devashish is showing us his session is turning in a very interesting points, and hopefully you will like it. And if you have any question, doubts, feel free to ask in the group, and we are happy to help. You can reach out to Mr. Devashish and or Mr. Karthik. They are all already in the group if you are looking for any for the job ready training, and they have the more